Okay, so I'll be presenting with you automated adaptive speech tutoring with context-dependent speech recognition. And this is a work I collaborated with Miyaki Takashi and my advisor, Rekimoto. So this work is about shadowing, which is an effective way to practice speaking by repeating a speech template as close as you can. Here's a video that shows you how to do it.
I've been so interested in why we have little engagement in work these days. It's a problem all over the world. And yet the happiest people that I know.
Okay, you got the idea. So as you can see, the shadowing is very easy to implement. You can just use any text or sound file as a template to do it. And many studies that shows shadowing can help with many aspects of speech, such as fluency, pronunciation, rhythm, or so on. But however, shadowing is hard to do actually. And for beginners, what usually happens is they got stuck into the speech when trying to catch up with the template. And whenever that happens, a practice cannot continue, and they have to manually adjust the practice to recover it.
What separates the best from the rest is they take action around it. What separates the great ones is simply
yeah, like this.
Dreams. And what separates the great ones is simply they never leave the sight of a new idea without taking.
Okay, you get the idea. So there are also actually studies that shows people are giving up shadowing because it is difficult. And on the shadowing topic, there are some related work. For example, an example given here, it's a system. It's actually a software that evaluates the pronunciation of a shadowing speech. Actually, there's recordings of shadowing speech. So it's not in real time, and also it doesn't really help with the problem that happens when practicing shadowing. Okay, so how can we help with this problem? The first thing that I noticed is that how about we add some pauses into the speech, and the reason for that is because in our natural conversations with others, usually we don't speak a sentence like non-stop. For example, in the sentence given here, why would you stay at home when you can work and earn money? If we say it like, why would you stay at home when you can work and earn money? Then it becomes much more easier for people to understand. So, but however, unfortunately, in shadowing speech, there is no such mechanism. So I'm thinking like, if people are starting to fail to catch up with the speech template, which means it's too difficult for them, how about we just add some pauses into the speech to make it easier for them to follow? And whenever a failure happens, instead of like manually recover the practice, there should be a mechanism that can detect when people are having this kind of trouble, and then automatically rewind the practice for them so that they can actually focus on the practice. So based on these two ideas, I created a system called WithYou, which can actually detect when people are falling back and then offers automatic playback with the pause modification. So just jump to here and show you how the system works. So people will start
the best from the rest.
There's a problem
what separates the best from the rest is they take action. What separates the best from the rest is they take action.
They take action around their dreams.
Makes sense.
So for the architecture of WithYou, it basically consists of two phases. And in the preparation phase, people prepare a speech template and the transcription text. And then based on these two files, the system can generate an alignment data which contains like the timing of each word appears in the speech template, and then use that to control the playback. And during the practice phase, speech, the user gives the shadowing speech, which is evaluated by the recognizer. And if there are any problem in the speech, the system will just add some pauses into the speech template and then automatically reply it. If there's no problem, then system will just compress them and then move to the next sentence. Okay, more detail with the implementation with speech recognition. We use Julius as an engine, and we use two-pass recognition as a strategy. The first pass recognition, which is fast and it can give the result like progressively. So it's a perfect match for measuring the progress of user speech in real time. But the problem is it can have some recognition problems, which can be recovered in the second pass recognition, which is heavy but very reliable. And we can also use that to compute the language quality evaluation, which we'll elaborate later. And also we use grammars as a language model to restrict the scope for recognition. However, the speech in shadowing is not easy to recognize, and it's mainly due to the two challenges. The first are because of the pauses caused by like being stuck in the speech, and usually a pause it's a terminator for the recognition process, and that's gonna cause problem for conventional recognizers. And also the repetition. Repeated speech is not something that repetition can be in shadowing speech very often, but repeated speech is not something can be handled by conventional grammar. So that's something we need to like solve. So for the pausing problem, we actually add a tail merging into a real-time speech. Like each time the system detects a pause, it doesn't terminate like immediately. It just waits for it will wait for a certain time to give the result. And I think it can cause some concern that okay, isn't that it's gonna slow down the practice. Well, actually, we can use this time to for other things such as for second pass evaluation. Also, we can use that to offer some vocal instructions to the user, so people won't really realize there's time for that. And the recognizer is also working fine. And for the second challenge is repeated speech recognition. We actually add a special entity into the grammar, which is called short pause, denoted as SP. And the function for that is they can actually connect the words that is adjacent to it. So as a result, basically, the sentence that has two SP at each end of the sentence can be repeated, and then it still can be recognized by the recognizer. So as an example for that, we give
your
a demo.
time is limited. Your time is limited. Your time is limited. So don't waste it living someone else's life.
Okay, so you can see repeated parts can be recognized perfectly. So based on this technology, we propose ways to detect shading failure in their speech. And basically for the fallback detection, we compare the real-time progress of a user speech with the speech template and set a threshold to detect if people are falling behind. And also, we don't want people to mumbling the words that are not correct for practice. So we added pronunciation evaluation method, which is called goodness of pronunciation, GOP. It's a well-developed method. I'll jump detail. We can turn to the paper for details. And we also ran the test to see if the proposed method can detect shading failure accurately. And it can, as a result, and it can detect 94% of the shading failure. But as a limit, it cannot detect like close mispronunciation problems such as breathe and breath. These very close words. Okay, so now we have the system there. We want to see how well that does shading help with shading. So we compare shading with conventional method from three perspectives: repeat accuracy, visibility, and cognitive load. So we ran a user study with that, and we recruited 8 people, which has medium high English level. And each of the participants will experience 2 methods to compare the efficiency of the practice by the procedure that shows in the figure. So basically, they have a training session of the method, and then after that, they have their shading performance evaluated before the training, and then they run the training with a method for 3 times, and after that, their sharding proficiency it's evaluated another time, and we compare this post-training test with the result of the pre-training test to see the improvements. And then they rest for 2 minutes and then run to another method. As a result, for repetition accuracy, if you look at the figure 1, it shows that for each of the single trial of the practice, sharding using WithYou can offer a better improvement compared to a conventional method with a sampler. And also, if we compare the result overall, participants using WithYou has a better improvement compared to sampler. And from the usability side, people really evaluate sharding using WithYou positively. So they think it's easy to do sharding with, and the system is very easy to use. They don't have to do anything actually in the middle of a practice. But for sharding using WithYou, using sampler, it's very difficult, and people read it very negatively. And for cognitive load, basically we measured 6 subjects from the NASA TLX, and the results showed that sharding using WithYou can offer like way much lower cognitive load compared to sampler, and noted that in the performance one, a higher value indicates a higher level of satisfaction. So in that case, WithYou it's also better than the conventional method. So what is interesting to observe from the experiment is that participants actually take advantage of the system and use that in a way that is totally unexpected from us, but it can help. They can use that to help with their practice. And the marked section here is from the participant 5, in which he actually just deliberately paused his speech so that the system will just come back automatically. And after the experiment, we asked him like, why would you do that? He's like, just there's some parts of the speech that he's not familiar with, and he just want to listen it like many times. So he'll just use it in that way. Okay, so for discussions, there are some, after the experiment, some of the participants mentioned that they want a performance report in the end, and also with explicit vocal feedback on the bad performed words. So those things are definitely something we can improve by incorporating text-to-speech capability into the system. And also, different people prefers different training strategy. Some prefers like starting easily, and someone prefers like starting with the highest level, and if they cannot catch up, they lower it down. So this optimum strategy for training each people can be explored by changing the way to modify pulses over time. And more importantly is that although this system is for shadowing actually is just one example of a bigger method for practicing speech, which is called oral repetition. It can have like many other applications, such as like practicing lines for acting based on a script, singing a song. And it turns out that shadowing is also a way for speech therapy for those who have difficulties to give a speech. So based on that, we want to explore like other variations to support our repetitions as well, instead of just shadowing. Okay, as a conclusion, in this presentation we give WithYou, which is an automated speech tutor with the ability to detect shadowing failures in real time and offer like automatic recovery and difficulty control. So a user study with comparing WithYou with the conventional method shows that it can improve repeat accuracy, and it's easier to use and can have lower cognitive load. So for future work, we want to integrate text-to-speech method for vocal feedback, and we want to explore more applications in other domains as well. Okay, that's the end of the presentation. Thank you very much. If you have any questions, you can reach me through the email from the paper. And yeah, thank you very much for your attention.